Hi, everyone. Good morning. I'm Dave Thau. People call me Thau. I'm a developer advocate at Google, and that means it's my job to work with people who are developing applications and algorithms using Google systems. And I focus on Earth Engine, which is our geospatial analysis tool, which I'm going to tell you more about today, and you'll have lots of opportunities throughout the day to learn more. This is Google Earth. I know from yesterday that you were all avid fans of Google Earth, and we love it. It's a great tool for visualizing the Earth and sharing information about it, but it was not designed to support analysis. You can't ask that many questions of Google Earth. For example, here's an area in Brazil that's changed a lot over the last 25, 35 years or so. Right? It went from just being one road kind of down the middle to a full city at the end. I was a little kid in 1975, and I was still in college in '89, and not long after that, it's highly developed. Now in Google Earth, you have lots of a global image and some historical imagery, but not so much. And the imagery that's in Google Earth has been kind of tweaked to look nice. Right? The colors have been corrected. It's been moved around. It's not a really good source for scientific analysis. And if you wanted to detect change here automatically, or even predict future deforestation, which is what this is, you can't do that with Google Earth. Now, luckily, if you're interested in doing that kind of analysis, there's lots of data available. Since the late 60s, we've been shooting satellites up into the air that have been taking measurements of the Earth. We have lots of data that have been collected by these satellites and others. And it is a lot of data. So Landsat 8 was recently sent up. It's collecting over 600 images a day now. Each one is about 100 miles by 100 miles, about 170 kilometers by 180. It's lots of information, not just the visual information that you see in Google Earth, but also infrared information, heat information, information about clouds. All that stuff is being downloaded many, many scenes at a time. There are over 3 million scenes now that date back 40 years. So there's tons and tons of information for people who want to do analysis. But unfortunately, it's hard to get at. This is the Eros Data Center in South Dakota. And these are some tapes that have data from some satellites. And for a long time, if you wanted a piece of satellite imagery, you'd have to pay, like for Landsat, you'd have to pay for it. And it would take a while to download. It was made, Landsat itself, which is one of many satellites, was made freely available in around 2008, but it's still hard to get the imagery. And even if you were somehow able to get all the imagery, it's a lot of data, and if you want to process it on your own machines, you have to have a lot of machines, and not everybody does. So we're hoping to solve those problems with Earth Engine. Earth Engine is our attempt to get rid of all the nonsense that you have to put up with before you even get started doing your job. The idea is to take all the data we can get our hands on and are allowed to share, and algorithms and the ability for you to write your own, and put them all in one spot and make it accessible to anybody with a web browser. So in essence, you've got access to an entire catalog of data, Earth observation data, a huge computational engine, and algorithms to run on that engine. So here's just one of our data centers. If you were in the Maps engine session yesterday, you saw that we have lots of data centers. These computers are answering search queries. They're helping you with your Gmail. But every once in a while, we steal a cycle to do some geospatial analysis. And since we have enough computers, we can do a lot. So I'm going to show you some examples of that, introduce the tools a little bit, and then throughout the day, you'll have more opportunity to learn more about them. Here's the kind of data that we have. So it's not just satellite data, not just Earth surface data. We have elevation data, atmospheric data, precipitation, and we also have access to vector data. So if you have vector data sets that you want to include, you can use those vector data sets, points and polygons. And you can also upload your own data using Maps engine. Now, we've been using this inside Google for a couple of things. One thing that's nice about having all this information is you can do lots of interesting historical analyses. So this is an area in Indonesia, and this is a picture from Google Earth not too long ago. This is the best shot we had in Google Earth of this area in Indonesia. Now, these are clouds. Clouds move. And if you have enough images, what you can do is you can kind of stack them up. And if you have an algorithm for figuring out what's a cloud and what's not, you can just look down the stack at every pixel. Is it a cloud? Yes, throw it out. Is it a cloud? No, choose it. And you can kind of go through the stack at every single pixel, finding a cloud-free pixel, and then showing that one. And if you do that, you could turn an image like that into this, where there's a whole lot going on in this area of Indonesia. This is Scotland, one of my favorite places. It always looks like this. But given enough time, you can see that, whoa, this is the city of Aberdeen, I think. There's something under there. So we did this for various spots on the Earth that were cloudy. And we did it for all of South America. And actually, we did it for the whole world and published that as the base layer of Google Maps and Google Earth. Okay, so the world never looks like this, right? I mean, there's not a cloud in the sky anywhere, and it's spring everywhere, right? The promised land. But this is now the base map. Unless you zoom, so we did all this work to get rid of the clouds, right? And then if you zoom out a little bit farther, you get clouds back. You get like today's clouds. It happened like the day after we launched. This is really ironic. We're like, yes, got rid of the clouds. Oh, now they're all back. But if you get right in the right spot, you get cloud-free image. And it's pretty cool that you get today's clouds on Google Earth. I like that. All right, so that's one thing that we did. We published that. Then we worked with a guy named Randy Sargent. I think you'll be meeting him later this week. To create a movie of change on the Earth over the past 30 years or so. I'm not going to show this, but Randy Sargent will show it. It's basically you can go any place on the planet, zoom in, and see how that place has changed over 30 years. And the idea there is we took a cloud-free image of every year for 30 years and composited it. So I'll leave it to Randy to show this off. It's pretty cool. But what I want to tell you is it took a lot of computational power. This was about a petabyte of data. We have many petabytes of data to store all the satellite data that we have. So it's whatever, 1 million gigabytes. It took 2 million CPU hours, so that's the amount of time on one CPU to process. If you had a one CPU computer and you ran this, it would take 250 years, which is like you send off your job and then you hope the power doesn't go out, or your internet doesn't go out for 250 years, and then like the Starship Enterprise beams down your data or something like that, right? Right. So rather than taking 250 years, it took about a day and a half. And that's because we could spread it out over 66,000 machines. Those are our applications. We've also worked with our science partners. So Matt Hansen, we worked with him to come up with a map of forest change over time over the 12 years from 2000 to 2012. You can zoom in anywhere and see when forest loss happened in this image, and that's the website for that. We're working on a number of new applications. So initially we worked on forest, but now we're kind of branching out into other areas. So one area is emerging infectious diseases. We're working with UCSF, University of California at San Francisco. There are folks here from there, on doing malaria risk prediction. So if you know precipitation, weather, greenness, you can predict when mosquito eggs are going to hatch, and then you can allocate your resources appropriately. So we're working with them to scale it up. We're also working with Stanford on predicting earthquake risk. So here's the San Francisco up there. We're down there around San Jose. This is some vector data. It's a fault line. Don't be too nervous. And this is the risk of damage at various points of the fault line. The point up there is San Francisco, where I live. The point down there is where Rebecca lives. Neither of us is, we're thinking about it too much. But this is another application of Earth Engine that this is using elevation data and our sort of processing engine. So here's how you can use it. Here's the website, earthengine.google.org. We have a GUI tool, graphical user interface. In the Earth Engine 101, Karen and Christian will go over that. There you can view imagery, so this is Landsat, and you can do all kinds of fun stuff, like you can train Earth Engine to recognize forest or not. So you can put down some points, say the ones that are green are forest, the ones that are red are not. And then have Earth Engine learn what's forest and what's not. So you'll see this if you're in Earth Engine 101. If you're inclined to program, we also have a programming interface that we'll be covering in 201 and 301. So this is the programming interface you see. It's JavaScript. It's fun. If you don't know how to code, I teach you everything you need to know in 201. I encourage you to come. And I'm just going to end with saying everything that we do is dependent on our partners. We're building a good tool, but it's totally useless unless we have experts who are using it. We're good engineers, but we are not domain experts. So we're really looking to you to come up with good applications of this tool to help you with your own work. So summarizing, Earth Engine, lots of data, algorithms that you can use that we provide, or you can write your own, and all the analyses happen on the Google cluster. Thanks.